Calculate the electric field intensity at a point 10 centimeter away from a point charge of 2 into 10 to the power minus 6 coulomb in vacuum. First, same thing, write down the given values. Okay, and what you have to calculate? Electric field intensity simply, and then you have to calculate the force. So first find electric field intensity. Same formula पे ही है. How to solve? First of all, write down the given thing. Okay, what is given here? Again, the electric field intensity at point 10 centimeter away. That means distance small r is equal to 10 centimeter. So 10 centimeter means 0.1 meter, right? And charge Q, how much it is given? 2 into 10 to the power minus 6 coulomb. So already it is given 2 into 10 to the power minus 6 coulomb. No need to change further. Okay, now electric field intensity is 1 by 4 pi epsilon naught Q by R square. So this is the electric field intensity, right? Now we know the value of 1 by 4 pi epsilon naught into Q is given 2 into 10 to the power minus 6 R square 0.1 into 0.1, right? Easy calculation, able to calculate it. Okay, so again do the same thing, 9 into, right, first of all 9 2s are 18, right, multiply 10 power 9 and minus 6, it should be 10 power 3. Okay, multiply, now 10 and 10, 100 will come up, so this is 10 power 2, so 18 into 10 power 5, right, 18 into 10 to the power 5. Now what happened? If you put 1 point here, 1.8 into 10 power 6, it will become 1.8 into 10 power 6 Newton per Coulomb. So this is the electric field intensity. Now the second is what? Also find the force experienced by the charge minus 1 into 10 to the power minus 6 Coulomb placed at that point. So again, we know that force is equal to what? Q into E. E just now you have calculated, and what is the Q? 2 into 10 to the power minus 6 multiply E is what? 1.8 into 10 to the power 6 Newton per Coulomb, right? Okay, so sorry, you have to take charge again, same 1 into 10 power minus 6 you have to calculate the charge, right? And then what happens? Same value you will get 1.8 because this cut, so 1 by 1.8 Newton per Coulomb is the answer. All right, it is minus means towards, so it is attractive, right? So this is how you have to calculate the force. Try another question. Two charges plus 2 and minus 3 mu c are placed 60 centimeter apart in air. Find the point on the line joining the charges where the electric field is 0. Also calculate the potential at that point. Okay. I guess we haven't done with potential, right? We haven't done with potential, so just left this question for now, right? When we done with potential walna, then we'll solve this question. Okay, अभी के लिए इस question को skip करते हैं, and then जब हम potential पढ़ेंगे, then आपको मैं ये question solve करूँगी, right? Now move towards the next question. Two three charges actually placed at the vertices of an equilateral triangle of side 0.5 centimeter. So here you have three triangle and the vertices having +2, -3 and +4 mu c. So +2, -3, +4 mu c. Right? Micro Coulomb will be the charge and they all are separated 0.5 meter. Am I clear? Calculate the net electric field at the position +2 mu c. So you have to calculate net electric field at this position. Find the force acting on +2 mu c. So like at this position only you have to calculate the net electric field as well as the force. Okay. Suppose this is a triangle. Let's A, B and C. Okay, triangle को A, B, C ले लेते हैं. Just try to solve it by yourself first. Got the answer, everyone? Okay, let's solve. So, first of all, just let +2 mu c at point A, 2 mu c charge at point A, -3 microcoulomb charge at point B and 4 mu c charge at point C, right? So now what you have to calculate? The net electric field at the position of +2 mu c. So first of all, what you have to calculate the first net electric field at point A. Simply you have to calculate the net electric field at point A. ठीक है, हमें A पॉइंट पे नेट इलेक्ट्रिक फील्ड कैलकुलेट करना है. सो फॉर दिस वी कैन यूज द वेक्टर एडिशन ऑफ द फील्ड, राइट? सो व्हाट यू कैन यूज vector addition of field due to B and C, because at point A, due to B and C, because if this is the triangle, right? So now see, if this is Q, right, and this is plus, this is minus, this is again plus. Okay, so now with this charge it will experience the force in this direction, electric field in this direction, due to this the electric field in this direction, and so what you have to calculate? The net electric field due to both the charges. Okay, so magnitude of electric field due to each. So how you have to calculate? First of all, calculate the electric field at point B, right? So at point B it is 9 into 10 to the power 9 multiply, right, 3 into, like the first charge due to B. At point B you have to calculate na. So here you have -3 mu c charge, right? So 3 into 10 to the power -6 by r square. How much? 0.5 into 0.5. So how much it will be? So ultimately when you calculate you will get 1.08 into 10 to the power 5, 1.08 into 10 to the power 5 Newton per Coulomb. Just solve it by yourself. ठीक है, एक बार खुद से सॉल्व करके देखना, you will get same thing and towards the B. All right, then EC. Now electric field due to point C. Right, what will be the electric field due to point C, guys? Same here, 9 into 10 to the power 9 multiply. Now there is 4 Coulomb charge, so 4 into minus 6, again 0.5 multiply 0.5, right? And how much you will got when you solve this? 1.44. 44 into 10 to the power 5 Newton per Coulomb, right? So now you know that it is an equilateral triangle, right? So the angle between each triangle is same, right? Each angle is same and it is what? Equilateral triangle hai. So we have a 60 degree only, right? How much angle it will form? 60 degree. So net, how you are going to calculate the net vector addition? Simply net electric field is under root EA EB plus EC EB square A square plus B square, right? EB square plus EC square plus 2 EB EC, right? 2 EB EC cos 60 degree. Simple. Now just put the value of each of them, right? EB square is how much? EB is how much? 1.8, right? And in place of EC, put this value, right? In place of EA, put the value and cos 60 degree, right? So ultimately what you will get? 2.21 into 10 to the power 5. 2.21 into 10 to the power 5 Newton per Coulomb. See, I am just telling you how to solve this, right? अभी ये numerical है, इसको आप calculation है, just try to solve the calculations, right? Like this, you have to first of all write down what is given, which formula you have to apply and how to solve the question in a simple way. Okay, next what is given? Force, right? जो दूसरा आपको बताना था, find the force on 2 mu c, तो simple 2 into E कर लेंगे, right? So 2 mu c के लिए 2 और जो हमारा अभी ये ultimately electric field आया, right? So you have to calculate Q into E. 2 into 10 to the power minus 6 multiply 2.21 into 10 to the power 5. So when you solve it, what you will get? 0.44 Newton per Coulomb. So this is the force. इसको एक बार खुद से solve करिए. Try to solve it by yourself and try to get the answer. Okay, try to practice solving numericals, guys. Next question is, a ring of radius 10 centimeter, right? A ring of radius 10 centimeter carries a uniformly distributed charge 5 into 10 to the power minus 6. Calculate the electric field on the axis of the ring at a distance 5 centimeter from the center of the ring. सिंपल है. अभी आपको क्या करना है, देखो क्या कह रहा है, a ring of radius. Now you have a ring, right? Radius 10 centimeter है. Okay. Carries a uniformly distributed charge of 5 into 10 to the power 6. Now here it has a uniformly distributed charge Q. Calculate the electric field on the axis of the ring. Now this is the axis of the ring. So at the axis of a ring at a distance 5 centimeter apart, right, here you have a point, right, from the distance, यहाँ से center of the ring से 5 center. Calculate the electric field on the axis of the ring at a distance 5 centimeter from the center. तो center से 5 centimeter तो यहाँ पे आ रहा है, right? Center से 5 centimeter will be here only. So you have to calculate the electric field at this point, right? So what is given here? Capital R is given 0.1 meter, right? Capital R is given 10 centimeter na, to 0.1 meter. Now charge is given 5 into 10 to the power minus 6 coulomb. Alright, and now you know that you don't know the distance, like what is the distance, at what distance you have to calculate 0.5 meter. Okay, this is the distance at which you have to calculate the electric field intensity, right? So now which formula you will apply here? E is equal to Q x upon x is what? The distance, right? Or 1 by 4 pi epsilon naught also. 1 by 4 pi epsilon naught Q x by R square plus x square 3 by 2, right? This is the formula. So just write down the value 9 into 10 to the power 9 minus the value of Q is given how much? 5 into 10 to the power minus 6. X is 0.5. R square is 0.1 square plus 0.5 square. It is 3 by 2. Okay. So now just try to solve this equation. Okay, after solving this equation, right, the value you will get is 5.09 into 10 to the power 4. 5.09 into 10 to the power 4 Newton per Coulomb. Okay, so this is the electric field, value of electric field. So just try to get the formula. ये formula ही याद करना आपका main chunk है. Okay, just note down all the formula. What is the formula of electric field due to point charge, electric field when it is placed at a axis, when it is placed at a vertices, right? In इस तरीके से you have to write down all the formula for electric field, and once you have written, you are able to solve all the question.